So I am Mark Beauchart. My office has moved. If you've had me in class before, I used to be in 213. Now I've moved down to the hall to what's going to be the teaching hub in 244B. My office is right next to this, what's going to eventually be the student lounge. Nothing in there right now, but Dr. Coase is there along with me and Dr. Brown. Okay, so make note of that. Megan was very quick in moving all my stuff out, putting all her stuff in there, so I'm in a new location. And right now my new furniture is not there, so if you come to office hours, you'll have to move around the boxes. There's some boxes with stuff in them, which are not going to be emptied until I actually get my new furniture, which should be hopefully by next week. So hopefully you're all in the right place now. Okay, this is CSC 2310, which is object-oriented programming. And we're going to build on the stuff that you've been doing in 2100 and 2110, except for instead of using C++, we're going to be using Java. So I don't anticipate starting over from scratch. Java borrows heavily from C++, so even though we're not going to cover declaration of variables and that kind of stuff, we're just going to start using them. It should be pretty obvious what I'm doing, even though it's a new language. What we are going to focus on are the important differences between, at least as far as you got in data structures with C++, and doing a lot more stuff with objects in Java. Okay? All right, so let's take a look at the syllabus real quick and talk about how your grade's going to be determined. So first of all, my web page. You can either write down that address or get to my web page through the main computer science page. Okay, so you should always be able to find it. And of course, what you guys are going to be interested in is the first link, which has a picture of the book. Okay, so there's a lot of material in here, especially when we're just getting up to speed on how to use objects in Java, which the textbook doesn't actually cover. Okay, there's really a lot of, starting with the material that we're going to talk about today, a lot of not, programming specific type concepts that I will be drawing from your textbook. So it is possible, the stuff that I'm going to put on your exams is going to be covered at some point in lecture. So if you wanted to pull resources together and maybe share a copy of the book to save money, I don't have any extra copies from other classes that I usually accumulate several copies of a textbook. I loan those out. But for this particular class, I only have the one copy. So, if you wanted to try getting by without, as long as you can find someone that that has a copy of the book and you can borrow it if you absolutely need it. The programming stuff is not going to be from the book, but the short answer type questions that we'll be covering in class and some will be on the exam is going to come from the textbook. Okay? So let's take a look at the syllabus. Oh, by the way, you can find the calendar, which has in here when the programs are due and when our exams are. See if I can find something for y'all. Your first test is on October 4th. Okay, so that's got all our dates on it. If you want to find, also on my webpage, you can get to my schedule, which has my office hours. So I'm happy to help you anytime that you see an office hour listed here. If the door is closed, knock. Okay, I don't always keep track of exactly when office hours start. And in fact, at other times, if I'm not busy doing something, I'm also happy to help you. Okay, so we're not restricted just to office hours, but yes, I will put down whatever I'm doing if it's office hours time to help you if you have questions. So the main thing that I would like to warn you about is, and I'm sure you've heard this in your other classes, try to come get help. There'll be a day where I talk specifically about the next programming assignment. And it's probably on the calendar. Probably have that stuff listed here somewhere. And that's sort of the day that I hope that most of you will start working on the programming assignment. So don't wait until the day before the program is due. So we've got program 1 due here, and I've got a lecture on program 1 there. Okay, so a couple of weeks before the program is due, I'll dedicate a lecture to talking about it. And that's kind of when I would hope most of you would start working on it. So hopefully you'll come see me with problems, not waiting to the last minute. I have 80-some students in assembly. I've got 70 of you guys in here. If you guys wait till the day before the program is due, there's no way I'm going to be able to help you. Okay, classes are just too big. So if you get stuck on something, plan on coming to see me ahead of time. Okay, which brings us to the way that these various grades will count. Okay, so on the syllabus, let's scroll down. Here we go. So your grade is going to be based on 3 programming assignments, which will count 10% each. So let me write this stuff down. And 3 exams. Now, I usually tell my students that exams for this class are the most difficult to make up. Okay, I spend a lot of time trying to make up exams for this class. They're going to have to be somewhat shorter because, like I said, I've got 80 in assembly and 70 in here. So in order to have them graded in a timely manner, they are not going to be as long as I've made them in the past. Okay, that may be good, that may not be so good, because then each question is going to have to count more points. But I am going to try something a little bit different this semester with you guys, and that is the 3 exams are going to be weighted based on how well you did on them. So your lowest exam grade is going to be only 15% of your final grade, and your highest will be 25%. Okay? I haven't done that before, but it seems like it might be a good idea because, messing up one exam, if you do well in the other 2, with this new system, you can really recover from one bad exam. Okay? It's not completely forgiven. And oh, by the way, I also put 110 points on my tests. So there's some built-in extra credit, but rather than giving you a free curve, you've got to answer some questions to get the 10 points. Okay? So your final grade is out of 100, but I put more than 100 points on the exam, so it's possible to actually make over 100 on an exam. And hopefully that will be your lowest. Okay, make 110. Let that be your lowest exam. Okay, I guess I can't even rule out the possibility that I might decide to put more than that on there. It probably depends on the material. Okay, so I would prefer not to have to curve, and I think that this system gives me another reason to not curve. Okay, so even if you did bad on one exam, you can easily make up for it on the subsequent exams. And we'll work through an exam before I give the first one so that you can kind of see what the questions are going to look like. Okay? I'll just pull an old exam, we'll come in here and we'll work through it. Questions so far? Okay, so I'm not quite done. That's what, 90%. So something new because of the way that we restructured our classes is now this class is not 3-in-1, but this is a 4-hour class. So there's really only one grade. So somehow we have to fold in the lab that you guys will be attending on Tuesdays or Thursdays. Okay? So that's your final 10% of your grade. So lab is the final 10%. And really, there's no reason why that shouldn't be a good grade. As I'll cover in more detail in lab on Tuesday and Thursday, the system that I use for lab grades, it's pretty easy to make a B. It may not be so easy to make an A. It's almost trivial to make a C. Okay? So my idea of the lab assignments are like homework. Okay, they're meant to give you extra practice outside of class. And if you have no trouble with the labs, I really don't anticipate you'll have any trouble with the programs. Okay? All right, so we'll talk more about, that's all I'm going to say about lab. We'll talk more about the syllabus for lab when we get into lab. For those of you that are coming on Tuesday, well, that'll be tomorrow. So is there anything else? Got links here to examples and programs. The programs are all here. We're not actually doing the first one. We're going to be starting with the decorated pizzas one, but we're going to be doing these last 3. Okay? So I am well aware that, I've taught this class a bunch, and I've tried all sorts of different programs. The ones that are here are the ones that have worked the best over time. Okay? So I don't change them. I realize they're out there. If you wanted to find someone who had the class before, you're gonna be able to get their programs. Please don't do that. That will really affect your exam scores. And unfortunately, I know that kind of stuff happens, and I would like to count the programs more. Okay? I would like to not have the exams be a full 60% of your grade. But I am aware, bad stuff happens in a class like this, especially since the programs, I've really kind of decided what I think are good programs, and I like to keep them that way. If I come up with new programs every semester, a whole bunch of them are going to be crappy. Okay? Coming up with programs for classes that work well and cover the concepts and are not super trivial or not super hard is not an easy thing to do. So I kind of found a set of programs that I like. So please, now talking to each other about them, as long as you're not sharing code, that's fine. Okay? Words are okay. Explain a concept. But as far as giving you code, that's what I will do if you come see me and I think it's appropriate. So don't share code with each other. Okay? Other types of discussions are fine. And so on the examples page is where I'll start putting your lectures for this that we're doing right now. This one that's being recorded will be the first one up there. I've got old lectures. If you really just love listening to that stuff, you can watch some old lectures. If you really want to get jump start on a program, you come down here and watch the lecture for that program and start working on it. Okay, as long as you're doing the work and you're using the materials that I provided, you can start early. It's fine with me. Okay. As well as other examples that we work through in class. Eventually this list will get pretty long. It's actually towards the beginning of the class, like the next several classes, I'm going to add a whole bunch of examples on there because we'll be getting through the basics. Later on in course, there'll be fewer and fewer, during the course, there'll be fewer and fewer examples, but here at the beginning, there's going to be a bunch. So I've already got ready for what we're going to be discussing next time. I'll try to remember to have those links up before class, so if you want to download the code and have the finished product while I'm discussing it, that would be fine. Okay? I may forget, so I can't promise that will always be the case. But at some point, those examples will be placed up here. I think that's everything on the syllabus. Any questions?
Does your GUI code work on stuff other than Windows?
Well, Java is platform independent, so should. Yes. Yep, should work. Anything else?
Is there a particular operating system that makes it compiling easier or anything like that?
Well, the easiest thing would, so as far as getting help from me when you come to the office, the easiest thing would be Windows.
Okay.
Okay? So if you don't have a preference, then go ahead and use Windows. But Java is platform independent, so if you want to use something else, I'll try to work with you. But getting help from me is going to be the way I like it to work is I like you to put, in fact, that reminds me, no, we'll discuss that in lab tomorrow. I like you to put the compiler that you're going to download as part of the first lab on your jump drive, okay? Because it's much easier for me in my office if you can say, I'm having trouble, here's my program, here's my jump drive, put it in there, let's take a look at it. It's a lot easier for me to work on my screen than your itty-bitty laptop screen, okay? So as you'll probably see once we start doing code in here, I like stuff to be big, it's easier for me to see. So ideally, you'll have the compiler on your jump drive, okay? And that makes it easier for me to give you help during office hours. Yeah, but more about that tomorrow in lab. So your first lab is there's really nothing to do. Everyone's going to make an A on the first lab as long as you come to the lab. We're just going to get the compiler and make sure that we can compile and run a simple program. And then you'll be set for the semester as far as that stuff goes. Okay? The download contains everything that you're going to need for the entire semester. So actually the download, especially if we all download at the same time, might take a while. Okay? So if some of you wanted to be brave and go look at Lab 1 and get that download done ahead of time, that would be great. But Lab 1's easy. Okay? But I'll cover the syllabus for Lab 1 in class tomorrow. All right? Okay, let's start some material. Okay, so this stuff is from the book. So if you really want to try to avoid getting the book, if you take good notes and watch the lecture, you should be fine. But I do take a lot of stuff from the textbook, so if you wanted to get a copy of it, that would probably be helpful too. So we're going to start talking about what Agile is. All right, so software development involves a process. Okay, whether you're conscious of it or not, when you are doing a large project, okay, there's some sequence of steps that have to be accomplished at some point. And they include, I'll use the phrases that are in your textbook, although there's several words that I use interchangeably for some of these steps. Requirements, which I frequently refer to as specification. Design, which I frequently refer to as design. Implementation. Okay, tough crap. Someone giggling. Design, implementation, and maintenance. Okay, there are more. We could come up with more words to represent our process than just these, but these are the primary ones. Okay, what do they mean? Well, one of the things you're going to have to do is figure out exactly what the problem is. Okay, sitting down and writing "Hello World," maybe you don't have to worry too much about specification, but anything that has some level of complexity, like one of your programming assignments, you got to make sure that you understand what it is you're trying to do. So, nice thing about that is that's done for you. You go read the assignment that I've given you, and that's your specification. But if you're developing for a client, you're going to need to figure that out, exactly what it is they need. You're also going to have to come up with the design for the software. You're actually going to have to sit down and code it up, that is, implement it. And then you're going to have to be able to, over time, fix bugs that the client uncovers, add on new features. If they really like the software product, they're going to want it to do more, and that's the maintenance step. Okay? Now, what does Agile have to do that? Well, to describe Agile, let me describe the old system first, and we can then compare and contrast what Agile is trying to do versus what old software development processes tried to do. So there used to be this system called the waterfall model. And when I started teaching computer science, Agile wasn't all that popular, so I discussed the waterfall process when I first started teaching the introductory level courses. Okay, we used to teach the intro courses in Java, and C++ was the third course, and now it's the opposite way. Okay, so a long time ago, the waterfall model was what was still discussed in classes. What the problems with waterfall model, here's the way it worked. The idea is make sure that you understand all the requirements before you do anything else, which that's common sense. Let me make sure I understand the problem before I waste time trying to design and implement the solution. So it kind of makes sense that would be the first thing to sort of develop once software development became a big thing. Okay? Make sure you fully understand the requirements before you move on. Then thoroughly think through your design. Okay, decide, we're going to be talking about classes and objects. Decide what classes you need, who's going to do what, all that kind of stuff, before you start coding stuff up. And then hopefully if you've done all that correctly, if you followed the waterfall model exactly and made sure that you understand all those phases before you moved on to the next one, the only thing you'll be doing in the maintenance phase is adding on new features that your client like. Okay, you've already shipped what they originally requested. They're happy. They want you to put some new changes in there, and you're happy to charge them more for that. Okay? So, probably a reasonable thing to come up with at the beginning, but there are serious problems with it. Okay? And they're really not the programmers or the software development people. It's not really their issue. The issue is the client. Okay? the client does not know what it is they actually need. They have some vague idea and maybe a few well thought out ideas, but in terms of the overall project, they don't know. So this is impossible to know that completely at the beginning. It's going to be uncovered when you start making it to the implementation phase and they say, yeah, I don't really like the way that is. We really wanted something a little bit different. Well, the waterfall model would then basically say, go back, forget all the design, the implementation that you did, go back and rework your requirements and start over. Okay? So it's just not good in the real world. So when you're in a classroom, it seems to work pretty well. It makes some sense. But in the real world, that's not the way things work. Okay? So what Agile is going to still have these things in it, but it's going to take a much more flexible set of rules into account that include the fact that the client doesn't know what it is they want. So if we can come up with a system that builds that in from the beginning, then we're going to have a much easier time developing that software. Okay? So, copied right out of your book. Agile methods. Value a move. In fact, I could probably find it in the book, but that would take several minutes. It's somewhere in chapter 1. Value a move towards the defined goal, that is working software, with speed, while maintaining the ability to change to a better route. Without great costs, which is what we incurred in the waterfall model when we realized that the client, we didn't have the requirements right. So now it's going to cost us a lot of money to go back to the beginning and restart the waterfall process. Okay? So our defined goal, of course, is code. To have an actual written software product. Okay? One thing I forgot to mention is the waterfall model has lots of documentation. I have to document all the requirements. Once I've done that, I'm going to document how I want the design to look. And of course, as I'm implementing the code, I want to document it. Okay? So there's lots of time spent writing documentation and not programming. Agile would much prefer us working towards the defined goal earlier. That is, producing code rather than all the documentation. Okay? So there's some things to do this stuff. There's some ideas that the software development team has to, buy into in order to make this Agile method work. Okay? So let me list some of those. So first, can we kind of see how this is going to be better? What we're going to do with our client instead of the waterfall model where we had to go back to the beginning when they made a change is we're going to write short little, we're going to implement small pieces of, they're going to give us some of their requirements. Okay? And they may change their mind, but we've got to start somewhere. And it's okay, we anticipate that they're going to change their mind, but still to give us a starting point, they have to have some clue of what it is they want. So with that starting piece of information, we're going to go ahead and start coding up something that does a little something along the lines of what they wanted. And then we're going to let them get their hands on it. Okay? And if it was what they wanted, great. We'll do the next small little thing. But chances are really good, even right there at the very beginning, they're going to say, well, let's tweak this a little bit. This isn't quite what we wanted. In fact, we decided that's not important. Do something else. Okay? That's okay. We haven't invested that much time. So if we need to make changes to that small little bit that we did, fine, go ahead and do it. Okay? If they decided they wanted to start over from scratch with something different, they changed their mind completely, well, we haven't invested much time in that one feature that we implemented, so okay, we're cool with that too. Okay? But we have to buy into a few things here to make that work. And that is, instead of relying on documentation, let me write that bigger. I know my writing's terrible. It's even worse on this thing. So instead of documentation, trust individuals. In fact, that whole idea of having documentation in the waterfall model was to sort of control what people were doing at any time. Make sure they're working on those requirements by producing documentation. Make sure they're working on the design by documenting that. Okay? Well, we don't want to spend all that time working on documentation. So we're going to trust individuals to be doing what they're supposed to be doing. Now, does that mean we can't get rid of documentation completely. Okay? It would certainly be nice at some point to explain why we designed something a particular way, and of course to explain what our code is doing. That's still important. But not this. Not producing reams of documentation at each phase in the waterfall model. Okay? But that doesn't mean don't document. Even though I don't grade for documentation on your programs, there's 70 of you, that would take forever. Okay? It's still important. It's going to be on your exams. I'm going to have you document stuff on an exam rather than in your programs. So I still expect you to know how to do it. Okay? All right, but the focus changes. So instead of relying heavily on documentation to provide focus to the team as they're developing the product, we're just going to say, yeah, here we've decided we're going to work on this small little piece. I trust you to do it. Okay? We want working software. So when we do these small releases to our client to make sure we're on the right track and make sure they haven't already changed their mind, we want it to be bug-free. So we are going to be, one of the things we're going to be learning in this class is test-driven development. Okay? And that means that we want code quality in addition to functional quality. Okay? So whenever we're preparing to give another little piece of work that we've accomplished to our client, or maybe even to another group and within our software development team, it has to pass all the test cases that we've developed. For the old stuff that we've already finished and for all the new stuff that we're working on. Okay? Because as you guys know, when you make changes, you break stuff. So as we add on, start building a bigger and bigger product for our client, we need to make sure that all the old stuff still works. Okay? So this does bring in like the documentation for waterfall, which is a big overhead burden on the waterfall model. Having a bunch of test code is an overhead burden on test-driven development. So I'm not saying Agile solves everything. It's just a better way of doing things than what's been done before. Now I have to have the code that corresponds to my actual product, and I have what's increasingly getting bigger and bigger, probably rivaling the actual code in size, is all my test cases. So I've got two test code bases that I need to maintain. Okay? But the reason for all that test code is to make sure that we always have, our program always works like it's supposed to. That's functional quality. We're going to talk about reliability in a later class. Okay, that's talking about does it work? And passing all the test cases is one way of making sure that works. It doesn't guarantee it does, but certainly if it doesn't pass the test cases, we know it doesn't work. Just because it passes all the test cases doesn't mean it works. Okay, I'm sure you've discussed that in the class before. But another thing we want to do is have code quality. Okay? The idea being here, have our code be of sufficient quality that it's self-documenting. In fact, we're going to look at the following iterative process for developing code. Let me just move 3 all the way off of here. So A, write some code. B, run against test cases. all the old ones and any new ones that correspond to that new feature that we just put in there. It's got to pass them all. Okay? That takes care of our functional quality. C. We're going to be talking about refactoring in here much later. But what that is now that I've added in some new code, I'm going to make changes to it to improve the quality of the code itself. I already know the thing works, okay, because it passed the test cases. But now I'm going to rewrite the code some to make sure that the code itself is high quality. The higher the quality of the code, the less documentation I need to put in the code. It will be self-documenting as much as possible. Well, what do you think I need to redo after I refactor? I got to test it again. Okay, so refactoring implies that, yeah, after you've changed the actual code, intending to leave it exactly the same functionality, but improving the way you've structured the code, yeah, you can break it. Okay, so this also involves testing. And then finally, number 3, which is customer collaboration. Where we expect to have access to the client. This system does not work if we can't have our small releases, let's call them. So we need to have someone involved with our client that can work with our small releases. So every time we have a new feature that we want to see, is this what you actually wanted? There has to be someone available to actually run that program and see if that in fact is what they needed. Okay? So if we don't have that the customer involvement in what we're doing in Agile, that it makes it much more difficult to apply Agile. And then finally, we have to be able to respond to change. One of the main things in our Agile quote from earlier, we need the ability to change to a better route without great costs. So in fact, if we do have this customer collaboration and they run through one of our small releases and realize that, hey, that isn't really what we need. Okay, we need something different. Well, all we invested was that last small release. So it's much more cost effective at that point to say, okay, we need to change direction now. Okay, so the amount of time involved when we took that last step and realized that that was not now the right direction, the amount of work that was wasted is minimal. Okay, so we can just say, okay, fine, we'll take that last thing out and we'll start working on a new one. Okay, so we have to be able to respond to change. So there are 4 variables associated with the software development project. One of those is obviously cost, time, scope, and quality. Okay? Which one of these did we just discuss a few minutes ago?
Quality.
Yeah, quality. Agile assumes that we're going to have high quality. Okay, I guess we did mention cost as well. Yes?
What did you say the second one?
Time.
Thank you.
Okay? Those other, something, in order for us to be able to make Agile work, and we're not willing to sacrifice quality, one of those other variables has to be something that can in fact change. Some of them are going to be pretty much fixed, and some of them we're going to allow to vary. But quality is not something we're going to allow ourselves to vary. We're going to go through that step where we test our code, refactor, test again. We're always going to make sure the quality of the code is high. Okay, so that's fixed. So the very first question, your first test, don't put quality as the parameter that's allowed to change. It's not. It's going to be high quality and Agile. Okay? In the waterfall model, that's not the case. In the waterfall model, frequently cost, time, and scope, we got the requirements. This is exactly what it is that we have to do. Okay? We know what they're going to pay us, so we know how many sophomore developers we can assign to this project. That's our cost. We know when it's supposed to be delivered to the client, and the requirements told us the scope. So none of those things is variable. So the thing, when we get behind schedule, the thing that suffers is quality. Okay? So we're changing that around with Agile, as well as the other changes we've already discussed. Quality is going to be fixed. It's going to be high. Okay? One of these others is going to have to be variable, and we could argue about which one that might be. But in Agile, the way that we're describing it in the book, we're going to assume cost is fixed. So we're going to assigning a certain number of developers to work on this project. Okay? And we could argue about either one of these. What most Agile textbooks talk about, however, is they also have a deadline for when it should be delivered. Okay? So then what varies is the scope. So remember the way Agile is working. We're adding on small features one at a time, letting the customer evaluate it, maybe changing direction. So when we run out of time, okay, they know exactly where we are because we have customer collaboration. When their deadline approaches, they know exactly what features they were originally thinking about, made it into the project, and they probably got some features that they realized later into the project. Okay? But probably their original idea, not all that stuff made it in. And the reason is we wanted to make sure that the quality was high and didn't want to sacrifice quality to get all the features in that they originally specified. But this should really not be a problem if we have the customer collaboration. They know exactly what features we've been working on. So the set that we actually have done in the time limit that's given to us should still make them happy. Okay? And I'm sure that we would have made it clear to them if they want, the rest of those features done, we're going to need more time. Okay? We're not going to rush through them and slap them together and have them not work correctly. Okay? So I guess you could argue that also what if the customer doesn't really have that tight of a deadline? They're flexible there. Well, then you could imagine let time be the variable factor. Okay? But the answer on the exam, according to your textbook, we're going to assume that they do have a deadline as far as time goes. So the features that get implemented is the thing that's going to vary. Could be more or less. I mean, it may be that we were able to do more than they originally specified because they never changed direction during the course of the product development. Okay, what they originally said is what they consistently said all along. We got all this done and we got some time to do extra stuff. Okay, but more than likely, the scope is going to have to be less than they originally had in mind. Okay. I think that's all I wanted to say about that. So let's take a look at a really simple Java program now. Which we'll expand upon in the next couple of classes. We'll do a lot of showing you the basics. So, and hopefully a lot of it will be familiar because Java is built or was designed based on the C and C++ syntax that you guys know from your previous classes. Okay, so let me just show you the directory structure too. So I've got a source and a build directory. We're going to be working with some batch files and some XML files. Oh, by the way, so the batch files aren't going to work if you use something other than Windows. You'll need to use a shell script. Okay? But it's probably going to functionally do the same stuff our batch file does in Windows. And I've had students successfully do that. It's not a big deal. So I've got my source in a source directory. And I've got two folders inside my source directory. CSC, well, I guess it's time to change that, huh? 2310. Okay? Which is where we're going to be working today. We are going to use some stuff from this util directory that's got some very useful Java classes that I use over and over and over again in projects. Remember, that's code reuse is an important concept. You probably discussed that in data structures. Well, let's look at this driver.java. So the first thing is when you hear me use the word driver, that is the Java program that contains the main method where your program starts. Okay? So we've got this rational driver that contains a main method as well. But that's more tuned to what we're going to discuss in a couple of classes from now. Okay? This one doesn't do anything meaningful at all except show you some of the initial, well, what you need to get a program to actually do something. Okay? Nothing useful in this case, but something. No, look for another app. Let's try to find Notepad.
Submit your code in Paint.
Yeah.
It's like you failed college.
Okay. So here's some basic code that really just reads in a couple of numbers from the user. So let me describe what's going on here. First of all, we've got this package statement at the top. And it says package CSC 21. Well, guess what? Okay. It's got to match the directory that the code itself is in. So all these other files are also going to have a package CSC 2310 on them. Okay. We'll talk about why that package mechanism exists in a later class. But it does do some very useful stuff. For your purposes right now, it's just syntax I got to have. Okay. You've got to tell which of those folders the code is in. The stuff in the util directory is going to have package util. Okay. The stuff in the CSC 2310 directory has got to have package CSC 2310. You can also have code that doesn't live in a package, but you know, as we're trying to do stuff right in here, and using this package stuff is what we're going to see later, the correct way to do things. Okay, right now it's just annoying. Now, import, what does that kind of sound like? Pound include. So I'm simply saying that I'm going to be using some code from a different folder, i.e. a different package. Okay, I'm going to go over into the util directory and use something that's in there, namely the keyboard class right there, keyboard.java. Okay, so I'm using stuff from a different package. If I want to use files that are in the same package, import is optional. Okay, but if I want to use something that's located in a different package, I got to specify it using an import statement. And I've got to tell which package it's in, i.e. which folder to look in. Okay? And everything is inside a class, but in our driver class, we're going to have this long, boring syntax that you got to have to indicate where your program actually starts. Now, I can have other stuff in here, other procedures and stuff, but we won't worry about that just yet. Okay? So the main method specifies where the first line of my program is. And all I want to do with this program is get some input from the user, but notice I say here, do not use the scanner class. So please heed this advice. If you want to save yourself a ton of effort, especially when you come see me in the office, and you've got all the scanner code in your program, and I say take it all out, we're just going to use the keyboard class. You've got this important, very, very important word that we talk about in programming. I know you've seen this one before. Abstraction. What does that mean?
Hiding things from the end user.
Yeah, let's hide the complicated details. Let's hide the complicated stuff and try to make it as easy for the user as possible to do whatever it is they need to do. So, in fact, the reason why the scanner class exists in Java at all, okay, I'm not going to ask you about the scanner class other than today's little discussion. It's not going to be on a test, is because it makes I/O somewhat easier than it would otherwise be. But for our purposes in this programming class, we really don't need all the functionality that Scanner provides. So I hid that from you inside keyboard.java. I use Scanner to do the actual file I/O, but I'm now hiding it inside the util directory. Okay, it's there. If you really want to see how to use it, you can look at keyboard.java and it's all in there. But I'm not going to ask you about scanner stuff on the test. It is too complicated for what we need to do in this class, especially at the very beginning. Okay? So I really have hidden all that complexity inside this keyboard thing. And here's how easy it is now to get information from the user. If I want an integer, I'm just going to say, we got this variable up here, which is a keyboard thing. I'm going to say kb.readInt. That's going to get an integer from the keyboard and store it in a variable. Okay? Can't get much easier than that. If I want a floating point number, i.e. a double, I just say kb.readDouble, and inside the parentheses here, I give the prompt that I want the user to see so that they know what it is I expect. Okay, so if I want an integer, I've just got an integer. If I want a floating point number, I've got the appropriate prompt for that. Okay? All the complexity with the scanner doing whatever it's doing is hidden inside that other file. So I'm using, from the very first example that we got here, we've got a very important example of abstraction. Okay, that's what it's all about in computer science, is using abstraction to make your life easier when you need to write software later. Okay? Okay, so let's run this thing and see how awesome it is, and probably find out that it's not going to work very well. So the way that I've got, as we'll see in lab tomorrow, and on Thursday, for those of you that are in the Thursday section, the way I do stuff is I've got this batch file set up, so all I have to do is tell it the drive letter of my jump drive, and that's where all that my compiler is. So it's going to be able to find my Java stuff because it's on E drive. Okay, or whatever letter happens to be assigned to my jump drive. I pass that letter to my batch file. It knows it's going to figure out how to find the compiler and all the other stuff it needs. So right now I should be able to say build E, and it should compile and then run my program. And we'll get into all the nitty-gritty details at some point later. Okay, so what happened here?
Change the rest of the package.
Yes. So it's still looking for package CSC 2120, which we made a big production, or I made a big production out of changing that. So I'm going to have to change something inside this XML, which I didn't really want to show you today, but oh well. Not what I wanted. Okay. So here I need to change that to, I need to send it to Notepad. Okay, let's change this to 2310. And I'm pretty sure I'll have to change, I'll go ahead and change this one too. Pardon?
Does Notepad have a find function so you can look
Oh,
at
yeah.
references?
Yeah, you can. Yep. Okay, let's try that. Okay, it's actually working, but you couldn't tell. It actually looks like an infinite loop. So there is one annoying thing. I'm using a build tool called Ant, which we're going to spend several lectures on later, that when you want to get input from the keyboard using my keyboard class, unfortunately, it wants you to provide the input before it gives the prompt. So it's actually working, but I have to be clever enough to know to give it the numbers. So there's a reason why I went through that, even though it doesn't make me look very good. And that's a trick that you're going to find very useful when it comes time to debug your programs. Okay? And that will also solve this problem. So we're going to kill two birds with one stone. Okay? If I want to get my input from a text file, which is what I want to do here in this simple example, I can simply provide a text file and give it all the inputs that I want. That's going to be useful when it comes time to debug your programs, so that you don't have to type in all that stuff over and over and over and over again. You type it once inside an input file, and you can keep running your program and fix the bugs. Okay? Saves a lot of time with debugging. So I can tell it to get the input from this text file very easily. And oh, by the way, sometimes your output is going to be, this probably happens to you in data structure, so long that you can't see everything here in the command prompt. Okay? Fix that too. You can specify an output file. So all the output will also, so we'll read the input from a separate text file, we'll write the output to a separate text file. Okay? Let's do that. So build E, the way I do that is I use these pipe symbols, the less than and greater than. If I use less than, that means don't pretend like you're getting input from the keyboard, but actually pull it from the file. Okay? And then if I use the greater than, it says pretend like you're printing to the screen, but actually print to a file. So with that, my program runs. I can open up output.txt, and I see that I've got, it looks like you would have expected to look. So if I want to just do the input, not the output, okay, it read the input from a text file. So that's a neat little trick that can actually save a lot of time. And there's other ways you could do it. You could have the program itself read from a text file, but that's a lot more overhead. Okay, much easier to out here at the command prompt simply pretend like you're reading from the keyboard, but read from a text file. Okay, a lot easier to do. We don't have to deal with reading and writing files and all that jazz that I'm sure you did in other classes. Questions? See ya.